Distinguished guests and colleagues, good afternoon. It's June 11th, 2021, 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Alena Kosareva. The thesis is submitted for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 010205, mechanics of fluids, gases, and plasma. The topic of the thesis is non-equilibrium flows containing carbon dioxide behind shock waves. Under the order issued by the Academic Secretary of St. Petersburg State University as of March 24, 2021, number 2219/1, I, Anatoly Rybinin, Doctor of Sciences in Physics and Mathematics, Senior Researcher, Professor of the Department of Hydroaerodynamics of St. Petersburg State University, was appointed the chairperson of this dissertation board. The order also approved the candidacies of the members of our board, and let me introduce them. To the right, I have Maria Radalevskaya, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Hydroaerodynamics of St. Petersburg State University. To the left, I have Vladimir Peterhof, Doctor of Sciences in Physics and Mathematics, leading researcher at the Federal Research Center in Informatics and Control of the Russian Academy of Sciences. And to the right, I have Mikhail Chernyshov, Doctor of Technical Sciences, Associate Professor of the VNME, Baltic State Technical University. And we also have a member of the board who is working remotely. That's Konstantin Volkov, Doctor of Sciences in Physics and Mathematics, Associate Professor at the Kingston University, London, UK. Do you see us and hear us, Konstantin? Yes? Yes, I do. And we also have the thesis supervisor of our candidate for the degree, Ekaterina Navnibeda, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Hydroaerodynamics of St. Petersburg State University. I would also like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted into English. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Ms. Alena Kosareva online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I'll read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and do not forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or dissertation text will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. Our dissertation board consists of 5 people. Everyone is with us today, including one member of the board who is working remotely. We have a multimedia connection with all the members of the board as well as with our candidate for the degree. Therefore, we have the quorum. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements, and chairman's replies to questions, if any. 5 minutes for that. Second, the candidate's presentation, providing an overview and findings of the research. 15 minutes for that. Then we're going to listen to questions to the candidate regarding the presentation, no more than 2 minutes per question. Next come the candidate's replies to the questions, 10 minutes for all. Then we'll listen to the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the candidate for the degree, 10 minutes per speaker. Then the chairman will deliver his report on the thesis, 10 minutes for that as well. Next come the candidate's comments about the reports on the thesis and replies to the questions, 20 minutes for all. Then we're going to have an open discussion. Anyone present at the defense may state their positions, or they can ask questions to the candidate for the degree on the thesis, 2 minutes per speaker. And I kindly ask you to fill in the registration form and introduce yourself before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. Then the candidate will reply to the questions. Then we're going to listen to the presentation of the candidate's thesis supervisor, 3 minutes for that, and then we're going to have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of these results is not broadcast. Then we're going to have open balloting, vote counting and recording of the results in the protocol. Then the board is going to make a decision on whether to confer the academic degree or not. And finally, we're going to listen to the candidate's closing remarks, no more than 10 minutes for that. So, distinguished colleagues, any questions or comments on our agenda? Okay, if there are no objections, let us proceed. But before we do that, I kindly ask you to switch off the sound on your mobile phones. So I start the session. The thesis by Alena Kosareva for the academic degree of the candidate of sciences in physics and mathematics. The specialization is 010205, mechanics of fluids, gases and plasma. Is titled Non-equilibrium flows containing carbon dioxide behind shock waves. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued March 3, 2021, number 1501/1. Ms. Alena Kosareva has prepared her dissertation at St. Petersburg State University. And Ekaterina Nagnebeda, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Hydro-Aero-Mechanics of St. Petersburg State University, is the thesis supervisor. 11 published works describe the research findings. And they include one paper published in peer-reviewed journals recommended by the Ministry of Education and Science, and 7 papers in publications indexed in Web of Science and Scopus. The candidate has submitted the full set of documents to the academic secretary, and the above-mentioned documents comply with item 12 of section 3 of the order. And all the documents submitted by the candidate for the degree, as far as I'm informed, comply with the requirements. They are kept in the certification file. And the curator of the defense member of the Department of Dissertation Board Support has all the copies of these documents. And before I give the floor to our candidate for the degree, distinguished colleagues, I would like to ask you if there are any general questions to our candidate for the degree. Is there a need to consider the full list of documents submitted? No, no need for that. Okay, Alena, now you have the floor. 15 minutes. Thank you, distinguished colleagues, distinguished guests. Today I would like to give you an overview of the results of my thesis, in equilibrium flow, non-equilibrium flows containing carbon dioxide behind shock waves. And here you see the short content of my report that is going to have introduction, basic theoretical component, and the results and conclusion. The need to study the flows of mixtures that contain carbon dioxide is something that is quite popular in many practical goals, for example, in modeling using the entrance to Mars atmosphere, and also in description of processes of that work with molecular lasers. And today we see that a lot of models were developed to describe such flows, including kinetic theory, and also based on the methods of direct statistical modeling. And the most exact and more detailed is multi-level approximation that is well developed, but due to the complex content of the molecule, such multidimensional studies are quite demanding, and we use multi-temperature and single-temperature approximations, especially in applied packages, due to the fact that they are simple and variable. And in my work, I use multi-temperature approximations. The relevance of this work is explained by the need to develop theoretically substantiated and simple multi-temperature models to describe the flows that contain the molecules of carbon dioxide. And also there is a need to validate models due to a small amount of experimental data and inability of flight experiments. And as for the practical value and scientific value, the elaborated recommendations and models should be provided on the speed of chemical reactions, and the results can be used to improve the accuracy of calculations of flows and in order to define dominating processes in initial conditions. And also we advise, our model allows to validate new models to describe oscillation shifts and chemical reactions using simple problems. And on this slide you see the goals of the work, and I'll shortly read them out. First of all, the systematizing of data on multi-temperature models as applied to the flows of mixtures that contain carbon dioxide. And also we should define dominating channels of relaxation in 5 and 3 component mixtures. We should develop 0 and 1-dimensional code for flows, and we should validate multi-temperature models within the program complex ANSYS. And I would like to first of all describe the structure of CO2. That's a linear 3-atom molecule that has 3 oscillation mode, extension, deformation mode, and asymmetric extension mode. And an important characteristic here is that the frequency of oscillation of the first mode is the double value of second mode. Represents the double value of second mode. This process is called Fermi resonance, and as a result of this process, the exchange of oscillation energies between the two modes can happen quicker. The kinetic model. When describing 5-component mixture due to complex construction of the molecule, the kinetic model should include the exchanges of oscillation energies between molecules of gas, and also there's a shift of translational energy to oscillation energy, and there are dissociation processes and certainly exchange reactions. And when we consider a shorter scheme, we should take into account dissociation and exchange of oscillation energies between carbon dioxide molecules, and also shift of translational energy to oscillation energy. And when describing the flow in kinetic code, we should understand the distribution. Translational and rotational relaxation happens quicker than oscillation relaxation and chemical reactions, and take into account the quick exchange between symmetric and deformation modes. we can say that in approximation of harmonious oscillators, the distribution looks like that. And we have oscillation temperatures here as well. And in a simplified case, if we believe that intermode exchanges happen quicker than transitions, we can introduce Boltzmann distribution using general oscillation temperature, TV. And then I would like to shift to multi-temperature description of 5-component mixture, taking into account this correlation. For characteristic times of processes, we can use 5-temperature approximation, and oscillation temperature is given for united mode, for asymmetric mode, and 2 atomic molecules. And the equation system that describe the flow in 5-component mixture will look like that, and it will include chemical kinetics for all components, and also oscillation kinetics for antisymmetric mode, and also for 2 atomic molecules and others. Now a few words about relaxation terms. In such equations, we use simplified characteristics using relaxation, and we calculate approximation of experimental data. Here I'd like to note that these approximations have corrections for high temperatures, and they can be applied in high temperature flows. In order to describe the chemical reactions using 5-component mixture, relaxation terms will include the following terms that are responsible for dissociation and recombination of carbon dioxide molecules, and also relaxation terms that are responsible for exchange reactions. And I would like to remind you that when we consider 3-component mixture, we'll take into account just the first term for dissociation of carbon dioxide molecules. As for speed rate coefficients, we used a Triana-Marron model for the calculation of dissociation of carbon dioxide molecules, and also an important point is that we use multi-temperature models for exchange reactions, and equilibrium coefficients of dissociation speed were calculated using 3 most widespread models. And then I would like to give you the results of my work. They are divided into 3 parts. The first part will be dedicated to spatial relaxation of non-thermal conducting mixtures, then the movements behind shock waves, and double-dimensional flows, and implementation of models in ANSYS. And let's start with spatial homogeneous relaxation. We consider 3 and 5 components mixtures based on multi-temperature approximations and a single temperature approximation. And we consider the following effects. And in my presentation, I would like to dwell upon the influence of the content of the mixture and scheme of reaction. Initially, we believed that the mixture contains molecules of carbon dioxide, and the following values were given for pressure and temperature. And on this slide, you see the solution that we got for 5 and 3 component mixtures with similar initial data for 3 temperature approximation. And here you see the division of temperature of gas and then the density of CO2 molecules. And we see that at the initial point, and we see it in both parameters. At initial point, the relaxation happens similarly for both mixtures, because the initial point, the mixture was considered to contain just CO2 molecules. And temperature processes are similar as well here, but we should note that there's a difference between the chemical relaxation and restoration of equilibrium. The gas temperature in 5-component mixture drops quicker due to additional VV and VT channels, and shifts to lesser values. And when we can consider density in 5-component mixtures, we see increased values for CO2 molecules, because part of the energy that we have in the system is spent on other chemical reaction like dissociation and exchange reactions. And here we can conclude that the use of more widespread scheme of reaction and more complicated mixture may lead to differences in flow variables, and when we consider more complex viscous flow, the difference in temperatures may lead to the difference in thermal flows. In the second part, I'm going to give you the information on the flows behind shock waves, and here we considered 5 temperature approximation and also simplified approximation to describe 5 component mixtures. We considered the following effects. In general case, the solution was received in conditions necessary for entering of Mars atmosphere. And here I would like to mention that resolving this problem, it's important to define the parameters behind the front of the shock wave, and quite frequently we use Rankine model. In this work, still the parameters behind the front were recalculated using the inflow parameters using a system of equations with the preservation of mass, energy, and oscillation energies when we consider multi-temperature approximations. And initially, I would like to draw attention to the oscillation, the effects of oscillation excitation for CO2 molecules. First of all, you see the conditions, moderate excitation, and also equilibrium state of inflow. And to the right, you see the temperature profiles behind the front of the shock wave. And when we consider the cases, we see that gas temperature in the majority of cases monotonously drops. But when we consider the conditions, this condition, the temperature of gas rises a bit, and this means that exchange mode is actively participating here compared to asymmetric mode. And when we consider the third and fourth case of excitation, temperature profiles are no different. And in this case, the influence of generalized mode is not that strong. And even moderate excitation leads to significant difference in gas temperatures inside this front and in non-equilibrium parameters. And then I would like to give you the different impacts of oscillation distributions. We considered 5, 3, 2, and 1 temperature approximation, and this shift from 3 to 5 temperature approximation was secured by the inclusion of non-equilibrium characteristic. And at the initial point of time, the mixture contained just CO2 molecules, because that suits the description of atmosphere in this case. On this slide, you see the distribution of gas temperature and the coefficient of dissociation speed received in these approximations. And when we compare temperatures, we see that behind the front of the shock wave, the gas temperature in single temperature approximation is rather variable. In one temperature approximation, it's believed that all the oscillation processes happen inside the front, and behind the front we have just chemical relaxation. And as for multi-temperature approximations, we have a drop of temperature due to oscillation relaxation. Comparing 5 and 3 temperature approximations, the values of temperatures are different, but not significantly. And when we compare the coefficient of dissociation speed, we see that behind the front there is a delay of dissociation in multi-temperature approximations, and in single temperature we see the dissociation that starts at once. And using this slide, we can conclude that the shift from one temperature approximation to multi-temperature approximation is important, and it influences the flow parameters. But shift from 3 to 5 temperature approximation, if we believe that the inflow contains just CO2 molecules, the influence of 2 atomic molecules is not quite significant. And we also carried out the comparison of different chemical reactions for equilibrium models. We've taken certain content in the inflow with a mixture of 2 atomic molecules and atoms. And you see the distribution of temperature. And the goal was resolved when we considered 3 different models: the Park model, Mackenzie, and the Ibragimova model. When we compare temperatures, we see that Park and Ibragimova model gave closer parameters for temperatures and for density, whereas using Mackenzie model, the profile of temperature is shifted, and chemical relaxation starts a bit later. And we see it in density model as well. And the highest speed was received when we used the Ibragimova model, and this complies with a swift drop of temperature and density. And on this slide we can say that using equilibrium model can influence the structure of shock wave where we have active chemical reactions. And now I would like to give you the information on the third chapter of my thesis. And we carried out two-dimensional calculations, and the main goal was to compare flow characteristics with experimental data. We considered the flow around the cones of different configurations with a 5-component mixture and different reactions. The inflow conditions were as follows. You see them on the table. And that's cone apex delta. It varied as an experimental work, and we had two different options of flow. In small angles, we had joint shock wave, and in large angles, more than 60 degrees, we had a reflective shock wave. And as for border conditions, we provided that the wall was isothermal with adhesion conditions and non-catalytic characteristics. And then I would like to give you the comparison of the heat flow along the cone with experimental data, and each graph complies with the cone angle. So there are different configurations, and the calculations were done using full reaction scheme. You see in red the use of reduced scheme without taking into account reverse reactions and recombinations in green, and the calculations were done for chemical frozen flows, and these results are given in blue. And when we compared heat flows, we saw that the calculations using full scheme of reaction comply with experimental data for all configurations of cones, and the use of reduced scheme or frozen flow gives us reduced values for thermal flows. And we can also mention that the results for heat flow that we got in frozen flow in small angles resemble the result that we got when we considered reduced scheme, because in this case more important is reverse reaction and recombination. And yet another comparison of standoff distance to different conditions. Here on X we have different cone angles. Each spot complies with configuration, and also the scale of shock wave according to Y. And we see that there is comparison between experimental data, and the use of a reduced scheme gives us some reduced values for shock wave, especially for the right case. And we can see that the chemical frozen heat flux gives us the standoff distance that is 2 times higher than in experimental data. And as for the third chapter, I can say that taking into account the full scheme of reactions can influence characteristics, and we should take it into account therefore. And shortly, the provisions that I give for the defense. First of all, I've provided the results of calculation of multi-temperature and equilibrium coefficients for the speed of dissociation and exchange reactions. Then we had the results of numerical modeling for 3 and 5 component mixtures. Then results of application of multi-temperature models to shockwave mixtures, and numerical implementation using ANSYS Fluent was provided as well. The conclusions as follows. I've voiced them already, therefore I stop here, and I have certain recommendations that were devised based on my work. That's it. Thank you very much. So, any questions? Yes, Mikhail Chernyshev from Voinmer. So, at the beginning you say that the excitation of electron orders and ionization of emission does not influence the flow. Have you conducted certain calculations, or do you have any substantiation for this position, for this range of temperatures that you've chosen? Well, I presume that in these conditions that I considered the temperature up until 12,000 kelvins, electron excitation and electron orders demonstrate lesser influence. After 15,000 kelvins, we should take into account the radiation and electron excitation. I did not conduct such studies, but based on the literature, I can see that for these conditions, oscillation, excitation of chemical reactions play a role in the relaxation process. I believe I answered your question. Other questions? Yes, may I? I have the following question. Did I get it right that you calculated viscous approximation? The results of last chapter, that's viscous approximation, and the results of the first two chapters are on non-viscous flow. The thing is that mathematical model that you give on the slide is formulated for non-viscous flow. So that's quite a natural question based on which models you calculated the equations. Yes, I forgot to say that third chapter is dedicated to viscous flow. Any other questions? Okay, then I'll ask mine. So you say about 5 and 3 component mixtures. And where do we find such mixtures? In which atmosphere is in Mars? And 99% of Mars atmosphere contains CO2, and there are certain admixtures of nitrogen and argon, as far as I believe, but they are too insignificant, therefore we consider that to describe relaxation in Mars atmosphere, it will be enough to consider full CO2, and then it depends on the chemical reactions that we consider. If we believe that we take into account just dissociation and recombination, then we consider 3-component mixture, simplified. And if we consider some additional reactions, then the scheme can be expanded with exchange reaction and dissociation of 2 atomic molecules. Thank you. Other questions? Yes. Well, Alena, on page 19 of your work, and then you use this term numerical density regarding molecules of some other type, some other component. Is this term generally applicable? Because as far as I'm concerned, maybe I got it wrong, you are talking about the mole fraction. Well, in the first 2 chapters, I used relative numerical density, and molar fractions are used in the third chapter. And what's the difference here? Well, relative density is the density divided by some molecular density, and molar fraction, well, it's like similar. It's something similar. Yes, I believe. Okay, colleagues, other questions, if any? Okay, no questions. Now let's shift to the next item in our agenda. We got no external reviews for the thesis. So let's listen to our members of the board. As all reviews were already published on the St. Petersburg State University website, I offer to read just the basic points and questions and comments to our candidate for the degree, if you don't mind. Okay. Then let's start with Maria Alexandrovna. I wanted to say that my impression is as follows. Among the goals of the thesis, we had a goal of systematization. And we know systematization goals are quite important. So this systematization, in fact, is considered quite fully in the thesis. Yes, and it started in detail. And I would like to mention that the author got a lot of interesting results, and they have particular scientific value, and many of them are reflected in the provisions that were brought for the defense. And basically here I would like to say that for me, personally, this result was very interesting, that the transition from 1 temperature description to 3 temperature description gives us much more change, and it gives much closer correlations with the already existing results than the transition from 3 temperature to 5 temperature mode. And I believe that this result is, first of all, important by itself, because we understand how many temperatures we can use and what approximations can be used in distributions. And above all, it is kind of, well, support for the results in the works of Professor Osipov and Professor Uvarov. And they said that a lot depends not just on certain processes of collision, but also a lot depends on the change of different types of energy that we have in collision. So essentially, when there is a shift from one temperature to another, we consider the transition from the change in. So we either consider the full energy, or we consider that oscillation energy can have different distributions. And as for the result, this result that there is a shift from 3 to 5 temperature mode, and the fact that it gives lesser changes, it is associated with the fact that types of energy in both cases so in some cases we consider just oscillation energy of different modes, and it seemed to me that the results were quite interesting, that non-equilibrium character of the incoming flow leads to non-monotonous behavior of temperature behind shock waves. So I thought it was really fascinating. And generally I wanted to say that there are not just important separate results. The entire work represents a kind of logical system that was offered on the study of such mixtures that contain this important gases like CO2, such multi-atomic gases like CO2. And I liked the systemic character of the study. That's the first point. So everything follows its turn. And I liked this approach and shift from one temperature of consideration of different schemes of reactions. And I liked the descriptions of different reactions. So I believe we'll use it later on in many studies. So I offered to answer each question at once. Well, I had no questions in my review. Okay, then let's give the floor to Vladimir Alexandrovich. The microphone. Well, they said that initially I had to praise our candidate for the degree before criticizing him or her. Indeed, the work is quite a rarity because we have both theoretical and practical calculations, because frequently people do either models or computations, and computations are quite model ones. However, they are multidimensional. This flow of a viscous mode is very interesting, and I had an impression that by the results of the thesis we can already implement some semi-industrial or industrial programs. And that, to my mind, is the practical value of the work. As for some serious comments, I don't have any, but I have some, points like on page 26 you call full energy of mixture, but in fact that's full internal energy. Maybe it's a misprint. Then I, as a computation scientist, considered it quite funny that you don't give the system of equations in conservative form, as it's resolved numerically, and everywhere you write it in a non-conservative form. In chapter 3, when describing the details of computational grids, you don't give the height of the first grid, and it, by the way, defines the accuracy of computations in the boundary layer. But it should be mentioned that that's a rare peculiarity. All the computational grids are adapted to the front of shockwave, and few people do it, and it really increases the accuracy of computation. And the last comment on page 102, the author writes that the accuracy is 10%, and for such simple geometries, I believe you could have given 1 or 2%. And as the author used numerical fluent code, we know that this code is rather rough in computing ultrasound flows, so that's a concise issue, not an issue to Alena to consider. That's it. Alena, you can answer. Oh, well, first of all, thank you so much for the review. I agree with the first comment. That's a misprint in the formula. As for the second comment, I also agree, because I used the formalism for the system considering viscous effects, but using the data of third data, I published an article that has conservative description of the system, and it actually complies with numerical solution that was given in ANSYS. And as for the third comment, I also agree with it. And in this goal, when we consider the flow of cones of different configuration, the height of a cell in the grid made 3 and 3 micrometers in the nose part, and 4 micrometers in another part, and in. So, as for the fourth comment, I also agree with it. Maybe this was not very accurate wording. The difference of thermal flow is not higher than 10%. So we've found the difference between the most accurate and non-accurate computations, and the difference was 7%. And the difference between thermal flows that we got using 4th and 5th grades, most accurate ones, the difference is 0.5% here. So we should consider the lattice that we use to find this error. Okay, Vladimir, are you satisfied with the answers? Okay, now I give the floor to Mikhail Viktorovich. Distinguished colleagues, I'll start with one rule that I thought about when I read this thesis. That's the rule that was worded by Russian poet Nekrasov, and maybe he took it from Schiller. That there should be space for thought and a limited space for words. And I thought that the style is not just concise, but concise to maximum. And I thought that author tries to use 130 pages to give the results of 300 pages, but the author managed to do it, not to the detriment of understanding. And the work is very well structured. In chapter 1, author considers and constructs new physical and mathematical models. In the second chapter, she got model results, and in the third chapter, there is this discussion of these results, and we have practical implications there. So that is the structure that is recommended by international journals when you write a large article. The only difference is that you don't have a good introduction, and in such scientific articles, it provides the major practical value for readers of adjacent sectors, because the introduction gives the goals, it considers the previous works, it gives the detailed description of the essence of the problem, and this introduction can be used to understand all the work. But basically the structure of work is quite a good one, and it's well described. It uses very good language. There are certain drawbacks. For example, my comment 3 is the same that Vladimir mentioned about specific and internal energy, and I would like to add up that in the wording of conditions for compression waves. The condition for preservation of full enthalpy and full heat content is titled the condition for preservation of full energy. And yet another thing to mention is that this work not only has a huge theoretical value, but also practical value in the prospect. For example, next week in Tauride Palace, there is an international GLAC symposium on outer space, and I believe the listeners of this symposium will be quite interested to read this work and to see this work adapted to practice. Therefore, it would be wonderful if the author studied not just direct shock wave and direct compression wave, but also more complicated objects like oblique waves. And we've seen oblique compression waves due to the deviation of the wave in the third part of work, and it would be nice to consider the interaction of these waves of the reflection, for example, triple configurations in such mixtures, because talking about multi-atomic gases, and we are talking about perfect gas, and we can get a lot of interesting results, for example, triple configurations with a negative angle of the reflected wave from Lyudmila Gvozdeva. And it would be nice to see this work adapted to practice in the future. And I believe it will be of interest to Roscosmos agency, and to it will be interesting for other agencies of the Russian Federation. And as for the third chapter, the mathematical models that you develop, it would be nice to include them not just into Fluent, but also in some domestic developments, like Logos package devised by VNF. I believe we should develop domestic software, especially in such complicated conditions that we have. And what I mentioned is actually the essence of my first and second comment. And overall, I believe that the author certainly deserves the academic degree of the Candidate of Sciences in Physics and Mathematics, and the thesis is a finished qualification work, and it deserves the highest mark. And this is, by the way, supported by publications in the leading international journals. Thank you so much. Thank you, Mikhail. Yes, Mikhail, thank you so much for your review. I won't read out the first comment. I'll just read the answer for the first comment. The study of triple configurations of shock waves certainly are of particular scientific interest. However, in this work, these configurations were not considered. In general case, the flows in two atomic gases is different from multi-atomic gases flows, and based on the results of the triple chapter of the third chapter, we can say that the consideration of frozen flow leads to an increase of deviation of shock wave, and take into account non-equilibrium. It's certainly that the deviation will be small, and it will have an impact on more complex configurations. And as for the second question, was dedicated to this oblique leap of compression. I agree that that's quite a relevant issue, and this can be practically applied, and we can consider the results of Chapter 2 in future work. And third comment was about misprints. I also agree, and this was already mentioned when I answered the questions of Vladimir Alexandrovich. Thank you. Professor Chernyshov, are you satisfied with the answers? Yes, overall, yes. Okay, now Professor Volkov, you have the floor. Well, I won't read it fully. I'll just give you the basic advantages and give you the wishes, not just remarks. Well, to my mind, this thesis covers a very relevant topic, and all the provisions brought for the defense, and as well as conclusions and recommendations, are quite substantiated. The credibility and validity of results is supported by test studies and by comparison with different experimental data from different sources and the results that other scientists received. And this thesis has a high level of novelty and practical value that was demonstrated in the report of the candidate for the degree. And as for this work, I just don't have remarks, but rather wishes for future work. And to my mind, some images that the author gives in the thesis is a bit overloaded with information, and you give too many lines, and it would be nice to differentiate these parts of images in order to improve understanding of the results. And the second wish, I believe, we can pay more attention to literature sources that was published quite recently during the recent 3 or 5 years. In the work you give a lot of literature sources. However, to my mind, there is a need to pay more attention to the works that were published quite recently. And above all, that's a prerequisite for any publication in peer-reviewed journals. So that's basically not a wish, not a comment, but a wish for this work. That's it. Thank you. Thank you, Konstantin. Alena, please. Yes, Konstantin, thank you so much for the review. I would like to start with the first comment. The first comment was on the wording of general mathematical model. I agree with it. The revised model can be summarized for the class of linear 3 atomic molecules, NTO, CS2, and so on. But part of models, 3 temperature approximation of kinetic theory, can be studied only using Fermi resonance. And when we introduce some other model, the internal content is of particular importance. Therefore, unfortunately, we don't have an opportunity to get a very broad generalization of these models. And I also agree with second remark that in order to simplify, I should have divided the system into 2 subsystems and give the changing parts to describe the kinetic and a chemical model. I agree with the second remark as well. And as for the third one, I'll try to correct that as well. And I also agree with other comments, and in my literature sources list, I don't have enough of recent works, and that's my mistake. And on this slide, I give the most recent studies on the issue. And they describe the use of CO2 models in different spheres. For example, there are experimental works, plasma works, radiation effects works, and other non-kinetic models. Thank you. Konstantin, are you satisfied with the answer? Yes, fully. Thank you. Okay, and finally my review. In my review, I mentioned the relevance of the study, of the topic, the novelty of the results that we obtained, the credibility of the results, and I wouldn't like to dwell upon these issues in detail. I'd like to shift to the comments at once. I believe you should have given more details on numerical calculation method that you used in your thesis, and in particular in 3 issues you write that the solutions for equation systems for microparameters provide gearing methods, but you don't give the reference to the sources, and it's unclear how you actually implemented this model. Second comment. The thesis, the author writes that you provide simple approximation formulas to calculate oscillation temperatures, but it's unclear how this formula is allowed to reduce the resources needed for calculation. So you don't have information on the processes and so on. And then misprints. These misprints sometimes distort the essence. For example, the density of atmosphere in Mars is higher by several orders. But still, these remarks don't compromise the overall high value of the work, because these are either wishes or they just demonstrate that there was certain negligence, no more than that. And the conclusion is that the thesis is a finished qualification study that considers issues and goals associated, and they provide us a unified result, and such results are of theoretical and practical interest, and the thesis complies with basic requirements of the order number 6821/1 on the procedure of granting academic degrees at St. Petersburg State University. And I believe that Ms. Kosareva deserves the academic degree of the Candidate of Sciences in Physics and Mathematics and Mechanics of Fluids, Gases, and Plasma specialization, and Article 11 of the above-mentioned order is not violated. Professor, thank you very much. As for the first comment, I agree that in this work, I even prepared a slide In this work, in order to resolve the differential equation system, I used a Gear method. You see the scheme, how it was implemented, and due to the use of MATLAB system for numerical calculations, it provides a lot of practical opportunities, and Gear method was used in standard function here, the one that I actually used. So that's solver ODE 15S. And you have this references to the formulation of algorithm and to the implementation MATLAB. That's linked to. As for the second remark, certainly I agree with it. When organizing computations using non-equilibrium state and ANSYS package, the final parameter is oscillation energy. That needs to be defined. And that needs to be used to define oscillation temperature. And in order to define oscillation temperature, we needed to introduce linear equations, for example, Newton equation. Therefore, we use simple approximation formulas because it's quicker and more convenient. For some quantitative assessment of efficiency, I compared nonlinear equation using a MATLAB function, and it was 2 times slower than the computation that I used. And as for the results of the first two chapters in spatial homogeneous mixtures, I calculated using my own computer, and it took half an hour. And when we used other computations, for some of them I used my personal computer with 4 cores, but for more detailed computations I used the server for 24 cores with 162 gigabytes of operative memory. And I can give you the ANSYS version 18.0. And as for the assessment of time, for 12 cores I required 12 hours. Take into account the fact that additional computations were held for a larger period of time in order to secure the convergence with stationary solution. And as for comment 3, I agree, it was a misprint. Thank you. Thank you. Yes, I'm satisfied with your answers. Now we can listen to the guests. If anyone wants to speak out. Yes, please, Elena. Thank you very much. Kosareva Elena, Professor of the Department of Hydroaerodynamics. I would like to praise our candidate for the degree and the work. Alena, we know Alena for a very long period of time. She came to our department on the 3rd year, and she participated in lots of projects of our department, and she participated in the life of our department actively. And you can give any assignment to her. She never says no, and she's always ready to participate. So you offer a problem and she starts working at once, and she gets quick and reliable results always. And as for the work itself, there are no doubts that the level of novelty is really quite high, and a lot of work was carried out. And indeed, as Mikhail said, that you could write 300 pages, but actually it would be hard to read them. Therefore, I support this work, I support the candidate for the degree, and I urge the members of the board to support this work as well. Thank you. Thank you. Thank you, Professor. Thank you, Professor. Anyone else willing to speak out? Then we should voice the questions that were submitted during the broadcast. But as of now, we didn't have any of such questions. So, Ekaterina, now it's your turn. Could you please tell us about the candidate for the degree? Does it work? Okay, thank you. Yes, I'm pleased to say a few words about my student, how we worked with Alena. In our department, we had a rule that the supervisor should not talk about the work itself, and the supervisor should provide information about the student. And Alena took this topic. I took my topic for coursework on the third year, and then we had several studying years. Then during the master's course, she worked with me, and then she joined a PhD course. And right now she delivers a report on her thesis, PhD thesis. During this period of time, Alena worked with pronounced interest, and she was pleased to work. It was very nice to work with her. She learned a lot during these years, both in theoretical studies and in numerical modeling, and in analysis and representation of the obtained results, both on conferences and in articles. Alena delivered her reports at many conferences in our country and abroad, in St. Petersburg, Moscow, Novosibirsk, Kalushta, Milan. And on one of those conferences she got a certificate for the best presentation of work, and taken part in... Yes, she took part in 2, scientific schools of young specialists in St. Petersburg and in Novosibirsk. And she delivered her reports, and always she was quite positive about it. It was very nice to work with her, to talk to her, because she is quite a positive person, and she was quite positive about any offer. Deliver a report on the department session, write an article, whatever. And in Novosibirsk she got a certificate for the best presentation of her report. And in our university sent her to Germany to work at the Aviation and Aerospace Center, and she visited the center twice. She performed her work, and then she finished some stage of work. But after that, they invited her once again, and she was invited there for the second time to work. And they were quite satisfied with her work. She worked on grants at our university, and she really helped to document the works, to provide documents on the grants. So she actively participated, and in her work on her thesis, and on courseworks, and on master's course, and on PhD course, she was quite active, and she was very fascinated with scientific work. And I believe that after defense, Alena will continue working in science, and she learned it quite well, and it really works well for her. Thank you so much, Professor. Thank you. Distinguished colleagues, anyone else willing to give their opinions? Anyone present? Any other questions submitted online? None? Okay. Therefore, we stop the discussion and stop taking questions. And before we conclude, and before we shift to the final vote, I would like to ask the following question to the members of the board and to our candidate for the degree. Are there any comments or remarks on the procedure of our session associated with this remote mode? I want to solicit the answers from all the members of the board. Professor Ulyanovskaya, Mikhail? No questions? No questions? Okay, then we shift to the vote. And after that, no opinions will be taken, as well as no questions. Now it's 9 minutes past 3. distinguished members of the board, we have an opportunity to organize a 5-minute discussion to discuss the results of the defense. And this discussion will not be broadcast. How do you think, do we need such a discussion in order to discuss the results of the defense? Konstantin? I believe no need for that. There's no need for that. Okay. If we don't need it, we continue our session and we shift to the vote. And I would like to ask all the members to voice their opinions. So let's check whether we all hear and see each other. That's a question to Konstantin. No, I see you and hear you. Everything is okay. Therefore, I raise the question on the award of the academic degree of the candidate of sciences in physics and mathematics in specialization mechanics of fluids, gases, and plasma to Ms. Kosareva. So we're going to have an open balloting procedure. I would like to remind you that the decision of the dissertation board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people voted in favor. Maria, what's your opinion? I believe that the thesis deserves, it's really a good thesis, and the author deserves the academic degree of the candidate of sciences in physics and mathematics. Okay, Professor Peterhof. Yes, I also vote for the award of the academic degree to Ms. Kosareva. Okay, Professor Chernyshov, I vote for the award of the academic degree to Alena Kosareva. Okay, Professor Volkov, what about you? I believe that Alena deserves the degree of the candidate of sciences in physics and mathematics. And I, chairman of the board, Anatoly Rubinin, also believe that Alena deserves the award of the academic degree. Thus, distinguished colleagues and guests, I would like to announce that out of the present or for the 5 present board members, 5 voted for the award of the academic degree, no one voted against the award of the academic degree, and no one abstained from the vote. Therefore, we decided to award the academic degree of candidate of sciences in physics and mathematics in specialization 01, 02, 05 mechanics of fluids, gases, and plasma to Ms. Alena Kosareva. So, distinguished colleagues, due to the fact that our session is held partially remotely, I want to ask the members of the board, or maybe our candidate for the degree, I would like to ask you if there are any comments or questions. I need to get an answer from all the participants. No questions? No comments? Mikhail? No? Alena? No comments? Okay, in this case, I would like to give the floor to Ms. Kosareva for the finalizing remarks. Oh, Konstantin, I forgot to ask you. Do you have any comments? About working remotely? No comments about that. Okay, now I give the floor to Alena Kosareva. Thank you so much to everyone present at my defense, and I would like to particularly thank my husband and my parents for moral support. And also I would like to thank all the department, I would like to thank my academic supervisor for always being there for me, for working with me for all these years, and I would like to thank my co-authors, Georgi Shoev, and I forgot to give his name in the presentation, but we worked together on chapter 3, and this cooperation was very important for me, and I would like to thank colleagues from Germany, Professor Hahnemann, Klaus Hahnemann, for welcoming me in Germany, and all these contacts helped me to develop my work, and I would like to thank everyone present for listening. Okay, therefore I announce the end of our session, and we congratulate Ms. Kosareva. I would like to thank all the participants, and I ask you to turn off the broadcasting of the conference.